Interesting. Let me delay the questions until the panel. So now we will go directly to the break. Ask Me Anything with Gopal and Joost. You'll have sorry a few minutes less, but maybe we can take a few minutes over. We're not that precise. So.
Okay,
Gopal?
thank you very much.
Yeah. And Joost.
All right. So I think Gopal had prepared 1 or 2 slides that he wanted to show.
Yes. So if I can just screen share. Okay, the topics raised in the, can you see my screen in the workshop are very interesting.
Yes, we see your screen.
All right, so yes, okay. So I'm going to talk about automating common sense reasoning a little bit, which I see as the solution for solving many of the problems that arise given the fact that classical logic fails in many aspects. So there are very interesting questions in the workshop. I'm going to read them here. So the real question to ask is, why are humans better at reasoning than machines, and we're able to do far more complex things than classical logic can? And the reason, I think we've been discussing it all morning, our language has its own truth predicate. I mean, the human language, natural language in the language. So if a proof fails, we know what to do. Whereas classical logic does not, it simply gives up. And I gave this example in the morning. So consider road connectivity of cities modeled with a simple reach to predicate. So think of those as axioms for reachability between two cities. So if I ask, can Machu Picchu be reached from Quito? The query will fail because there is no direct road. But we can conclude that Machu Picchu is unreachable from Quito by road. We really need, in classical logic, separate axioms for unreachability. So the solution is to use negation as failure, which of course has been researched in logic programming almost since its inception. So the idea, if a proof fails, some action or conclusion can be predicated on that failure. So I might, for example, write a rule which says, if my proof for reach x comma y fails, then I will use a helicopter, reachability by road, then I'll use a helicopter to visit that place. And so for negation as failure, of course, answer set programming has been suggested as a paradigm. It supports support for sound negation as failure. So our thesis essentially is that, so the idea is to model somehow the human thought process. And again, this research also goes back, to has a long history. So the thesis is that human reasoning process can largely be modeled using deduction, negation as failure, default rules, possible words and abduction, and constraints or invariants, enforcing invariants. So of course, as I said, programming research, its systems have been around. Research is, stable model semantics is 30 plus years old. But a major roadblock is that ASP implementations are based on grounding and then obtain a propositionalized program and then use a SAT solver. So that prevents us from applying it to knowledge representation applications, because the knowledge base can really be large. And then if you ground it, you get, tens of billions of rules in propositional logic. So has had good success with optimization problems or constraint satisfaction problems, but not really with knowledge representation, I would say. So the solution is to design predicate answer set programming systems that are query driven, essentially prologue extended with negation as failure in the style of stable model semantics. And we actually that's what we've been doing. And I want to recruit you to using this system and developing applications available freely. So the idea here is to simulate an unerring human. And we've developed a bunch of applications. So with answer set programming, modeling the knowledge, and using this query-driven approach, we can actually build natural language question answering systems and chatbots that truly understand human dialogue. And in fact, we made it to this Amazon Alexa social bot competition where something like 400 teams apply and they select about 9-10 teams. And so we're really trying this technology, answer set programming, to build systems that are based on truly understanding the content of the conversation. And again, simulating human expertise, we actually build systems using this technology where we model a cardiologist that treats congestive heart failure. and the system actually outperforms cardiologists. So you can think of this as, with negation as failure, you can essentially build better expert systems. And then I mentioned earlier, deriving concurrent algorithms automatically from sequential algorithms. So essentially use the human model, the human expertise of a concurrent algorithm designer. How can I express the knowledge as axioms about concurrency, about data structures, locking mechanism? Given sequential code, how can I derive concurrent code automatically?
Gopal, this is supposed to be kind of an Ask Me Anything session, huh? It's
Okay,
not,
so that's it. And this is the okay, ask me anything with this background.
ask you things, and Joost is supposed to grill you. So.
Okay, all right, grill me, Joost.
Oh, I don't necessarily have to do it myself. I'm also happy to. I see in the chat that there's already someone else who has a question. So
yeah, but I disagree with Gopal because of his helicopter, if not reach.
Okay.
A human doesn't know helicopter if not reach. He knows helicopter goes to any point, and then if he have a problem of not reach, he will think to helicopter. I think that's a bit different. I don't know if you understand my.
Yes, I agree. So I'm simplifying it, you could argue, but we could model that reasoning as well.
Okay, that's great.
Yeah, so I'm oversimplifying, but the idea is to simulate human reasoning as much as possible.
Okay.
Okay, maybe I had a question as well. So a PhD student recently asked me, there were all these expert systems in the 80s and they didn't work, and now you're still doing logic-based, knowledge-based AI. What are you trying to do different that will
I think I would say that now we understand how the semantics for negation and negation as failure, I mean, we understand it much better. And we can do things, model the thought processes, human thought processes much better, I would say. That's the big difference. And the example I gave is this modeling a cardiologist treating a heart failure. And we tested the system with cardiologists, modeled it using default logic and ASP, and it is able to do better than a cardiologist, because humans will, again, cardiologists are well trained, but they forget things or they forget the rules. The rules are complicated. There are some 80 odd rules, and part of their fellowship is actually understanding and applying those guidelines and those rules that they have to follow. So yes, so it's just the advancements that we have made in understanding negation as failure.
Okay, I think we have to end the session, the Ask Me Anything session. So thanks very much, Gopal and Joost.
Thank you.
Yeah, I have a question, but we can ask in the discussion later or afterwards.
So now we go to the next session on logic and